In this experiment, students would study the air state changes within various sections of an air conditioner, and therefore to become familiar with the complete air conditioning process. It would enhance students' understanding the air conditioning fundamentals, psychrometry, and the use of psychrometric charts and refrigerant pH charts, and understand the energy balance on the air side and the refrigeration side in a direct expansion air conditioning system. The equipment to be used for carrying out this experiment is the air conditioning laboratory unit manufactured by P.A. Hilton. It consists of an air-cooled packaged condensing unit, a thermostatic expansion valve and evaporator. On the air side, it has air blower and air heaters. It is system diagram of the air conditioning laboratory unit. In the system, refrigerant is compressed and pushed to the air-cooled packaged condensing unit. The refrigerant pressure is lowered by the expansion valve and transferred to the evaporator. The low-temperature refrigerant at the evaporator would absorb the heat of air blowing from the fan. Passing the evaporator, air is cooled. At this moment, moisture would be condensed and collected. Then the air would pass through the air reheater to condition the thermal state before blowing. In Stage 1, students should familiarize with the setup of the equipment first. We are going to measure the dry bulb and wet bulb temperature. So, remember to fill up the bottle of wet bulb thermometers in order to keep them wet. Then check the thermometer locations. Finally, ensure that the inclined manometer is correctly connected and in working order. Before turning on the equipment, ensure that all heater switches are in the off position. Turn on the unit at the main power switch, and set the fan speed at 60% on the panel. Now the fan is running. Press the switch on panel to turn on the compressor. Switch on both the air after heaters. Other heaters are not required. Let the unit run for 5 to 10 minutes to allow it to achieve steady operation. During the experiment, please record the readings including the air temperatures, refrigerant pressures, and refrigerant flow rate. Record the air dry bulb and wet bulb temperature in various sections, from A to D. The airflow rate of the unit can be estimated with this equation. Measure the orifice differential pressure from the inclined manometer. Then read the specific volume of air of point D from the psychrometric chart. For example, at point D, the dry bulb temperature is 22 degrees Celsius and the wet bulb temperature is 17.5 degrees Celsius. On the psychrometric chart, read the dry bulb temperature from the x-axis, 22 degrees Celsius, draw a vertical line up. Read the wet bulb temperature on the inclined lines, like the blue hidden lines, around the middle of 17 and 18 degrees Celsius. Mark the point crossing the dry bulb temperature line. The specific volume of air are inclined lines like the green dotted lines. Then you can read the specific volume of air at the cross of dry bulb and wet bulb temperature. In this case, the specific volume of air is 0.85 cubic meter per kilogram. Record the refrigerant temperature and pressure at point 1, 3, and 4, which are after evaporator, before expansion valve and before evaporator. Finally, read the refrigerant flow rate and record the heater input. In this experiment, we propose to have 4 different sets, with fan speed at 60% and 10%, and heater at 1 kW and 0.5 kW. Remember, allow the unit to achieve steady operation after each step of setting before taking your readings. In the report, please plot the refrigerant cycle on pH diagram and air temperatures on psychrometric chart to obtain the air-specific volume and values of enthalpy. Then you can evaluate the heat added to the air stream by heater, cooling capacity by refrigeration cycle, and energy removed from air stream by cooling coil. How to obtain the values of refrigerant enthalpy from pH diagram? First of all, draw the pressure line of condenser and evaporator, that is the pressure before expansion valve P3, and the pressure leaving evaporator P1 respectively. On right-hand side of evaporator pressure line, point refrigerant temperature T1. Draw a vertical line down to the x-axis and you get the enthalpy H1. On the left-hand side of condenser pressure line, point refrigerant temperature T4. Draw a vertical line down and you get the enthalpy H4. To find the values of enthalpy of air, psychrometric chart should be used. On the left-hand side, you can find the values of enthalpy, which are on inclined lines highlighted with blue dotted. For example, if we want to obtain the enthalpy of air at point C, first, read the dry bulb temperature 17 degrees Celsius from the x-axis, draw a vertical line up. Read the wet bulb temperature 15.8 degrees Celsius from the inclined lines like the green hidden lines. Then you can mark the point C. Read the correlated enthalpy from the left-hand side like the blue dotted line. So you get the enthalpy of air at 44 kJ per kilogram. Now, you may know the method to read the values from the charts now. Please carry on and try to do the supplementary. Enjoy the experiment. Thank you.